let's take a look at how to factor using the difference of two squares method. The first thing we have to check for is whether this method will even work, and the name sort of tells us if it will work or not. So here's what we want to check for. First, we want to make sure that we are dealing with a difference problem, meaning we need to make sure that we have a subtraction problem. Next up, we want to make sure we're dealing with two terms, so a binomial, not a trinomial, so we want to make sure we have two pieces. And then we want to make sure that we're dealing with numbers that are perfect squares, numbers that you could take a square root of. So if you don't have your list of perfect squares, the first few perfect squares to check for, or to look at, are 1, 4, 9. These are like 1 times 1, 2 times 2, 3 times 3. So if I keep going with my list up to 100, I've got 16, 25, 6 times 6 is 36, 49, 64, 81, and then 10 times 10 is 100. Now obviously this list just keeps going on and on, although if you see any of these numbers, it's probably a good indication that you're probably going to be using the difference of two squares method. So let's go ahead and see how this method then actually works. So let's check and make sure we can factor it for this first problem, x squared minus 81. First thing is, it is a difference problem. I can see a subtraction sign. I can see there are two terms. It is a binomial, and last up, it is a perfect square because 81's in my list. So the way the method works is basically comes down to taking square roots. So if you're using a calculator for this, by the way, make sure you do square root of 81, not square root of negative 81. It won't work. You can't do square roots of negative numbers until you learn about imaginary numbers coming up in a few more videos. So I've got two sets of parentheses for this to work. The square root of x squared is just x, so put that in the first spot. Remember, we're just reverse multiplying, so if I were to re-multiply this with the box method, x times x is x squared. Square root of 89 is 9, so I'll put that in the back spot in both parentheses, and then the only difference is one parenthesis is going to be positive, one parenthesis is going to be negative. That's how the difference of two squares works. If you want to see why the signs are opposite, go ahead and re-multiply this using FOIL or the box method, and you'll see why opposite signs make that middle term cancel out. But if you don't care, then that's fine. That's just how the method works. So as I said in my other factoring videos, this would be a great time to pause the video and try these next ones to see if you have the idea down. Otherwise, if you're just watching to learn, you can let it play through, and I'll go through and explain how I did each of these. All right, so next up, I've got to check that this is even possible. So I have a difference problem with subtraction. There are two terms, 9 and 100 are both in my list, so this one should work with difference of two squares. So it comes down to taking square roots, and I've got two sets of parentheses. Square root of 9m squared is 3m. So both of those parts will be in the front, 3m and 3m. Square root of 100 is 10, so that's going to be in the back. And the only difference is 1 is plus and 1 is minus. So there's my factored expression. Now we get to ones that are a little bit more complicated, a little bit different looking. Let's see, first up, it's two terms, so check. It's a difference problem. 4 and 25 are both in my list, so actually I guess this one shouldn't be too bad. It follows the same pattern. So I've got two sets of parentheses. The square root of 4a squared is 2a, so put that in the front. The square root of 25b squared is 5b, so put that in the back of the parentheses. And just to show you, I can switch up my signs. I'm going to go minus and plus. Doesn't matter what order your signs are in as long as one's plus and one's minus. Okay. Be really careful here. It's two terms. 100 is in my list of perfect squares, but this problem actually cannot be factored. Do you know why? Did you just talk to the video? That's weird if you did. But the reason this can't be factored is, hopefully you said it, or thought it at least, this is not a difference of two squares. There's a plus sign there. We don't have a pattern for factoring the sum of two squares, so we cannot factor this problem. It will not be factorable. All right, and then for these bottom two, as you look at them, you may be tempted to think, well, these can't factor either, even though they're difference problems. There's two terms. 2 and 32, for example, are not in our list of perfect squares. So you're right, 2 and 32 are not in the list of perfect squares, but remember, no matter what kind of factoring we're doing, we're always looking for a greatest common factor first. So I didn't do it up top because there wasn't a greatest common factor besides 1, although we should be checking for that, be in the habit of doing it. Now we have to, because the only way to do this is to factor out the GCF first. So both terms here can be divided by 2. So I'm going to take a 2 out and rewrite this as x squared minus 16. And now if I take a look at the parentheses, now I do have a difference of two squares because 16 is in my list. So I'll take, or put down two sets of parentheses. I'm going to factor a second time to do this. X in the first spot because x times x gets you x squared. And then the square root of 16 is 4, so that goes in the back. And same pattern, the only difference is your signs for the pattern. So 1 is plus and 1 is minus, but don't forget to bring your GCF down and include that in front. If it's not there, it's not factored completely. So there we go. And last up, same idea. 8 and 18 are not in our list of perfect squares. Do not take the square root of 8 and 18 and get decimals. That's not how this works. Once again, my greatest common factor is 2. So I've got 4 minus 9n squared. And now this meets the requirement to be factored using difference of two squares. There's two terms in the parentheses, there's a subtraction sign, and 4 and 9 are perfect squares. So I'll follow the pattern again and take the square root of 4. I'll put the 2 in the front. I'll take the square root of 9n squared and put 3 in the back. Some people think it's weird when the variable's in the back, but just deal with it. If that's how the problem is, that's how the problem is. And then make one sign plus, one sign minus, and include your GCF in front. And there's the difference of two squares, factoring.